You know that feeling, right? You find this absolutely perfect data set, you're all set to dig in and find something amazing, but it's just so massive that it threatens to bring your poor laptop to a grinding halt. Well, today, we're going to tackle that exact problem. We're going to show you how to handle truly gigantic data sets, all without needing some crazy expensive supercomputer.
I mean, we've all been there. You find the data set, you fire up your script, you hit run, and crash. Memory error. It is the worst. That feeling of being stopped dead in your tracks, not by your code, but by the physical limits of your machine. So frustrating.
And just to give you an idea of the scale we're talking about, let's look at a dataset called the Pile. It's an 825 gigabyte collection of text. It's what people use to train those huge language models. Now, for most of us, just downloading that is a non-starter, let alone trying to actually load it into memory. Honestly, even a 40 gigabyte dataset is enough to give your laptop a full-blown heart attack. But here's the really good news. A library called Hugging Face Datasets was literally built to solve this exact problem. It's designed to free you from these memory management nightmares for good. So, how in the world does it work? Well, the first secret weapon we've got is a technique called memory mapping. This is the absolute key that lets us unlock these enormous datasets without trying to cram them all into our computer's RAM. And the result? It really does feel like magic. Okay, so if you've ever used a tool like Pandas, this rule of thumb is probably burned into your memory. The old school thinking is that you need a ton of RAM, way more than the actual size of the dataset on your disk. Well, we're about to see how we can just completely ignore that rule. Let's take a real-world example. This is the PubMed Abstracts dataset. It's almost 20 gigabytes of text just sitting on the desk. Now, if we were following that old rule, you'd think we'd need at least 100 gigs of RAM, maybe even 200, just to get started. And here it is. This is the magic right here on the screen. That nearly 20 gigabyte dataset on the disk, we're accessing all of it right now using less than 1 gigabyte of RAM. I mean, look at that difference. It's incredible. We get instant access to everything without paying that insane memory cost. So how does this work? The best way to think about it is with an analogy. Memory mapping is kind of like having a library card for your hard drive. Instead of trying to check out every single book in the library and stuff them into your backpack, which is your RAM, you just get a map. Your program can instantly find and grab any single piece of data it needs, right off the shelf whenever it needs it. And just like that, the RAM problem is, well, it's solved. Thanks to memory mapping, which is powered by this super efficient data format called Apache Arrow, the biggest bottleneck for most data work is just gone. We can now get our hands on a 20 gigabyte file almost instantly. Okay, so we've solved the memory problem, which is huge. But what about that 825 gigabyte dataset, the Pile, that we talked about earlier? I mean, most of our laptops don't have that much free disk space to begin with. So we've just hit a new wall, and this one's even bigger. And that brings us to the second killer technique, dataset streaming. This is the answer for when a dataset isn't just big, it's so ridiculously enormous that it won't even fit on your hard drive. The best way to wrap your head around streaming is to think about Netflix. When you watch a movie, you don't download the entire, multi-gigabyte file before you can hit play, right? Of course not. The data just flows to you in little chunks, right when you need them. Well, dataset streaming works in the exact same way. And that is the game changer. With a single line of code, you can start working with that entire 825 gigabyte pile, one piece at a time, without ever downloading the whole thing. The impossible just became totally possible, right from the comfort of your own laptop. So when you put these two things together, memory mapping and streaming, what does that actually give you? Well, it means you've basically just been handed a set of data superpowers. The old limits on what you can work with, they're gone. Let's take a look at what you can actually do now. Check this out. Let's say you need to combine two huge datasets. How about the 51 gigabyte Freelaw dataset with that 20 gigabyte PubMed data we saw earlier? Normally, that would be a nightmare. But with streaming, it's easy. Step 1, you load the first stream. Step 2, you load the second stream. And step 3, you just combine them, and it's instantaneous. No waiting, no memory crashes, you just get the result. And combining is really just the beginning. This whole streaming toolkit unlocks a world of possibilities. You can process elements on the fly, you can shuffle gigantic data sets, you can easily create your training and validation splits. All of these things now just work, no matter how big the data is. So here's the bottom line. The old barriers, the hardware barriers, they've been lowered dramatically. Whether a dataset is 20 gigs, 50 gigs, or almost a terabyte, you now have the tools to work with it right from your normal laptop. So the only real question left is, with all that power, what are you going to build first?